Hello, and thanks for clicking on this next Narculus production. Today, we're going to be talking about algebraic limits, part one. We're going to work with limits by substituting values in and trying to algebraically manipulate them to calculate a limit without having to go and make a graph, because that would be great. No one really wants to make a graph for every single problem to evaluate a limit. So let's get started and see how it works. All right, so we're going to start by evaluating some simple limits using direct substitution. Direct substitution is exactly what it sounds like, okay? You're going to take the value that the limit is approaching and you're going to substitute it in for the variable and see what you get. It's that easy, okay? Now, there's a little more technicality to it that we want to be careful of. So, for example, if I want you to find for me the limit as x goes to 3 of x plus 5 over x minus 4, basically what I'm asking you to do is the following. I'm asking you to take this function called x plus 5 over x minus 4. If you were to graph it, I want to know what y value this function approaches as x approaches 3, right? We did this graphically already. Okay, that's what I'm asking you to do. But I want to do this in a simpler way. So to do that, we can use the limit laws that we just learned in the previous video. So the limit laws say that if you have a limit where you have a function that's divided, you can divide the limits into two limits. So you can find the limit as x approaches 3 of x plus 5. Well, that would mean I take 3 and plug that in. 3 plus 5 is 8. And then I can find the limit as x goes to 3 of x minus 4. Take 3, subtract 4, I get negative 1. And then that means that the limit as x goes to 3 of x plus 5 over x minus 4 is actually equal to 8 over negative 1, which is negative 8. And that is the limit. So again, what does this mean? This means that on the function f of x equals x plus 5 over x minus 4, if I were to graph that function, then as x approached 3 from both the left and the right on that graph, the y value would be getting closer to negative 8. Okay, now let's talk about some technicalities or some mathematical notation. So what's important here is that you understand is that we are applying the limit laws to this. One of the most popular things that I see all the time is, well, it just says the limit as x goes to 3. So I'm just going to put 3 in, and on the next line, I'm going to write 3 plus 5 over 3 minus 4. So my answer is 8 over negative 1. It's negative 8. That is not acceptable. You cannot write that. One of the most important things you need to learn about this course is that it's not just your ability to do mathematics, it's your ability to understand mathematics and write proper mathematics, which for some of you may be your Achilles heel. It may be something that's going to be difficult for you to get used to. Okay? Mathematical notation here is important. So this would be marked wrong. It's not acceptable. There's no limit sign. There's nothing. So this limit can be evaluated because the limit laws allow you to split this limit into two separate limits. And then this limit evaluated gives you negative 8. Okay? So we are looking for proper notation here. I'm going to talk about that as we go along. So let's try this one on the bottom, because this one's a little more complicated. The limit as x goes to 3, the limit of 3 as x approaches 5. All right, so there's two ways to think about this limit. One of the ways to think about it is, well, normally I'd try direct substitution. I'm going to take 5 and I'm going to stick it in for wherever I see an x here in this function. But there is no x. So then I can't put 5 in. So the answer is 3. That's one way to do it. The other way to do it is also to understand it graphically. It's easy to understand graphically. F of x, the function, is 3. Well, f of x is just y. So that's the line y equals 3. Go up 3, make a line at y equals 3. As x approaches 5, from both the left and the right, the y value, well, it's 3. It's always 3. So this limit is equal to 3. Okay? All right. Now, let's make it a little more complicated. Let's find the limit as x goes to 1 of x minus 1 over x squared minus 1. So these are divided. I can split them into two limits. Let's do that. Limit as x goes to 1 of x minus 1 is 1 minus 1, which is 0. The limit as x goes to 1 of x squared minus 1 is 1 squared minus 1, which is also 0. So the limit as x approaches 1 of x minus 1 over x squared minus 1 comes out to be 0 over 0. Now, I'm not writing equals, right? There's no equal sign here. There's a reason for that. Because the question on the table is, what is 0 over 0? Well, my guess is you probably have one good guess, which would be 0, right? You have nothing, you divide it into no parts, you have nothing. But I'm willing to offer an alternate answer, which is, I believe you learned it like in maybe 3rd grade. If you divide any number by itself, the answer is 1. So like 2 over 2, that's 1. 3 over 3, that's 1. 5 over 5, that's 1. 10 over 10, that's 1. 1 over 1 is 1. Why wouldn't 0 over 0 be 1? So the question is, what is 0 over 0? 0 over 0 is considered to be what we call an indeterminate form. Indeterminate form. Okay? So 0 over 0 is one example of an indeterminate form. There are a lot of indeterminate forms, and we're going to talk about a bunch of them here in this course. All right, but this is our first one. And let's take a second to explain to you why 0 over 0 is considered to be indeterminate. I can do it pretty easily using what you learned in probably 3rd and 4th grade. Let's do some simple division. So you know already that, let's say, if I ask you to take 6 and divide by 2, I'm sure you know that's 3, right? But you didn't learn it as a fraction when you started. You actually learned it like this, probably. Wrote 2 into 6. So 2 into 6, you had to figure out 2 times what number would make 6. And you knew that's 3, so then you did 3 times 2, that's 6. And then you subtracted. 6 minus 6 was 0. So there was no remainder. So the answer to this problem is 3, right? So, I mean, it works the same way every time. I could do, 10 over 5. Well, you know that's 2. Why? Because 5 goes into 10. 5 times what would give me 10? 5 times 2 would give me 10. 2 times 5 is 10. I subtract them. 10 minus 10 is 0. No remainder. Well, if this works, then 0 over 0 is really just 0 into 0. So now, my question to you is, 0 times what number gives 0? Well, there's a problem with this, because 0 times 0 is 0, which would be okay if it wasn't true that 0 times 1 is 0, 0 times 2 is 0, 0 times 3 is 0, 0 times 4 is 0. So the question is, what number do I put up here? I can't determine it, right? I can't determine it. It says 0 over 0. Okay? So, hence, indeterminate form. So now, what are we going to do with this indeterminate form? This is not our answer, 0 over 0. Our answer is not undefined. Okay? So what are we going to do? We are going to try to algebraically repair the issue that we have with this function. So we're going to try to do some algebra. So I want the limit as x goes to 1 of x minus 1 over x squared minus 1. If you notice, you can factor the denominator. So we're going to rewrite the limit sign. X minus 1 over x squared minus 1 factors with the difference of two squares. X minus 1 times x plus 1. That allows me to cancel out the x minus 1s. So now we want the limit as x goes to 1 of 1 over x plus 1. That I can evaluate. Okay. The limit as x goes to 1 of 1 is 1. And the limit as x approaches 1 of x plus 1 is 2. So the limit then, as x approaches 1 of x minus 1 over x squared minus 1 is 1 over 2. 1/2. That is the correct answer. Okay. Now, in a previous course, probably in pre-calculus, you learned that when you crossed out this discontinuity, it was called a removable discontinuity, and there'd be a hole at the point 1, 1/2. That's certainly true. That's exactly what's happening here. There's a hole at that point, 1, 1/2. It's a removable discontinuity, and we're going to talk all about discontinuities coming up in a future video. But for now, the limit of this is 1/2. Okay? All right, so to fix an indeterminate form, we are going to ask ourselves this question. So 0 over 0 is our one indeterminate form so far. We're going to ask ourselves, WWA, a 1KD, what would an Algebra 1 kid do? Because that's probably what you should do. So Algebra 1 kids know how to factor. They know how to combine fractions. They know how to FOIL, multiply things out. They know how to multiply by a conjugate. They know a lot of algebra. And those are some of the techniques that you can use to get yourself out of an indeterminate form. Okay? All right, so let's try a couple more here. Let's try the limit as x goes to 5 of x squared minus 25 over x squared minus 4x minus 5. So first thing we're going to do is we're going to split the limits. X squared minus 25 as x approaches 5 gives me 0. And then the limit as x goes to 5 of x squared minus 4x minus 5 would give me 25 minus 20 minus 5, also 0. So 0 over 0 is indeterminate. Okay, 0 over 0 is an indeterminate form. So now we're going to go try to algebraically repair this problem. So we can do that by factoring the top and the bottom, right? Keep our limit sign. Factor x squared minus 25 into x minus 5 times x plus 5. And we can factor x squared minus 4x minus 5 as x minus 5 times x plus 1. Cross out the x minus 5s. That's good, okay? And you can see that's good because that has eliminated the 0 over 0 indeterminate form. Take a look, because what's happening? When I'm trying to evaluate this limit, x approaches 5. So 5's getting substituted in up here. 5 minus 5 is giving me 0 up there. And then whatever this is, who cares? 0 times it's going to be 0. And then down on the bottom, 5 minus 5 is giving me 0. 0 times whatever number that is 0. So my answer is coming out to be 0 over 0. By eliminating the x minus 5s, I've eliminated the indeterminate form. So now I want to calculate the limit as x goes to 5 of x plus 5 over x plus 1. So that's the limit as x approaches 5 of x plus 5, which is 5 plus 5, or 10. And then the limit as x goes to 1 of x plus 1 is 1 plus 5, 6. So the limit then, as x approaches 5, of x squared minus 25 over x squared minus 4x minus 5 is equal to 10 over 6, which reduces to 5/3. And again, we can also say that there's a removable discontinuity or a hole at the point 5, 5/3. Okay, which again we'll talk about more in a future video. But that is also true. All right, graphically. All right, and then finally we got one more here. Let's try to find the limit as x goes to -2 of x over x plus 4 plus 1 over x plus 2. All right, so let's take the top here, and we'll try to find the limit as x goes to -2 of that. So that's -2 plus -2 plus 4 plus 1. So that's -2 over 2 plus 1. That's 0. And then on the bottom, just for a change, -2, whoops, let's rewrite it first. We got x plus 2. That's going to be -2 plus 2. Also 0. 0 over 0 is indeterminate. So now, we want to algebraically try to repair this. What can we do? Well, up top, certainly, we can find a common denominator up here. So let's go ahead and do that. All right. So let's see. We got the limit as x goes to -2. And the common denominator up in the numerator is x plus 4. So I'd have to put a 1 underneath here and multiply top and bottom by x plus 4. If I do that, it gives me x. This one, it gets multiplied by 1, right? It doesn't change. And then the other fraction becomes 1 times x plus 4, or x plus 4, all over x plus 2. All right, we're still trying to clean this up a little bit here. Remember, you can hopefully see it. I need this x plus 2 to go away somehow, right? I need it to get canceled out because that's giving me 0 in the bottom. So somehow there's got to be an x plus 2 on the top that's giving me 0 up there. All right, so let's keep working on it. So we got x plus x, that's 2x, plus 4 over x plus 4 over x plus 2. All right, now we can simplify this. I want to simplify it into one fraction. I don't like these complex fractions here. So if you think about it, 6th grade style, x plus 2, or 2x plus 4 over x plus 4, that's divided by x plus 2. So keep this, change this to multiplication, and flip that over. So that's going to give me 2x plus 4 over x plus 4 times 1 over x plus 2. So like I said, I'm doing a little work here off on the side. All right, so that's 2x plus 4 over x plus 2 times 1 over x plus 2. Okay, oops, that should be a 4. All right, so now, remember, the goal is still to get x plus 2 to cancel out. You do not want to multiply x plus 4 by x plus 2. It's useless because you need the x plus 2 to cancel out. If you multiply it out, it's not going to be there anymore. You'll have to factor it to get it there, to get it back. So don't do that. Just leave it the way it is. So now you have the limit as x goes to -2. This is, I can factor out a 2 on top. Oh, there it is, x plus 2. And then x plus 4 times x plus 2 in the denominator. Those cancel out. That's good. That means I'm doing it right. So now I have the limit as x goes to -2 of 2 over x plus 4. So I can evaluate that. That would be the limit as x approaches -2 of 2. That's 2. And the limit as x goes to -2 of x plus 4 is going to be 2 as well. So the limit then, this entire limit, I'll come up here because I'm running out of room. The limit as x goes to -2 of x over x plus 4 plus 1 over x plus 2 is 2 over 2. It's 1. And that's the correct answer. And again, there's a hole at the point -2, 1. This is a removable discontinuity at x equals -2. Okay? All right, and that's how we evaluate limits algebraically. Okay, and as always, thanks for clicking.